All right, so this is fourth session of fourth chat session. Today we are covering chapter number 6. So this session is mainly for question and answer, but since no one is here, so I think there are no questions. But I want to go over the most important things in chapter 6, which is the topic of this week. So we are covering chapter number 6, and our chapter 6 is about statistical inference. So this is from your textbook, which is Business Analytics 3rd edition from Camm, Cochran, Fry, Ohlmann, and everyone. So some of the people actually are very famous here. For example, Sweeney. So I have read a lot of research papers from this person, and then Anderson, but I don't know Camm, like who's this Cameron, or I don't know Cochran or Fry. I have no idea, but some of them are pretty well known in the area. So chapter 6 is about statistical inference, and what it means is if we have a population and we have to find some information about our population, we have two ways. We have actually the best way is to ask the question everyone in the population. For example, if you want to know the age of your population, or you want to know what is the average age of the population. So one way is to ask the age of each person in the population, and then you can say, okay, we have got the age of each person, and for example, there are 3 million people or 30 million people. You check the age of each and every one, and then you say, this is the ages of 30 million people. Now add them up and divide them by 30 million. So this is the average age of the population, which is very expensive process, and everyone cannot do it. So for example, when we do census, we actually do exactly this thing. We ask a lot of different questions about their living, their salaries, their income, their areas, their age. We ask them their date of birth, where they're living. So we get a lot of data, but we technically ask almost everyone. So in census, we have a whole population and we ask questions from the whole population. That's why census is very expensive. But another way is to take a small sample out of the population and make an inference about the population. So instead of 30 million people or 3 million people, you say, I will take a sample of 300 people, and then I will answer the same question, like what is the average age of my population? And this is called inference. So statistical inference is actually, so we are studying statistical inference, and we are making inferences, or we are answering questions about population, but not from the population. We are actually answering questions about population from the sample. So there are two things. There is one thing is population, which is everyone, and then there is this sample. All right, okay. So these are the two things, and we are like, okay, we have population and we have sample. So population is assumed as large, is huge, and it includes everyone. Sample is just a small fraction of those people. So if we have a question, or if we want to know anything about population, we call it population parameter, or we call a parameter. So I'm giving you all these terminologies so that you can better understand concepts from the textbook. So once you will read the text, you have better understanding what's going on and what they are saying. So parameter is, you can say, it's a characteristic of the population. For example, if I'm saying average age, in the population. So what is the average? So if we have, I will denote this by capital N. So if there are 30, for simple, let's keep 30,000 people, and in one city, for example, Lowell, we have 30,000 people, and then we are saying, okay, what's the average age? And average age of this, which is a population parameter, we can denote this by mu. So mu is usually used for denoting average. So average age, and this is, I'm writing here small h. So mu is equals to sum of everyone's age, so xi over n. So what I have to do exactly, so this sum, which I just made it, sum is going from I is the first person, is going until 30,000 people, and xi is the age of each person, n, or I can say capital N here, is 30,000. So what I have to do, I have to ask each person age and then sum it up. So the first person age, for example, 29 years. The other person age is 59. Third person is 96. Then there's a 3-year-old, and then there is 10 years old, so on and so forth. And then in the end, I have total of 30,000 people, their ages divided by 30,000. So that's the common process. We take average, and we call this mu. So this mu or u, so we usually call it mu. But let's talk about sample, and this is very expensive process. So we cannot ask everyone age, even if it's 30,000. It can be really expensive. Forget about 3 million or 30 million, 300 million. So if you have to do it on US population, it's really expensive. So sometime, that's why census is done like every 10 year, 20 year. It's an expensive process. But we can say, okay, instead of 30,000 population, why don't we select few people and ask their ages and say that it is a representation of the whole population. So we select a sample of 30 people and say, what is the average age in this 30 people sample? So we denote this by, so this is sample is equals to x bar. So you have to see the difference. So here I use mu, and here I'm using x bar. So if you're using x bar, it means it's sample. So we are talking about sample. So it's a different notation. It's mu is a different notation. X bar is a different notation. And so what we will do here, we will do summation xi over n. So here, this 30 is actually n, and summation xi over n. And sometimes, like some people denote this as a capital X, so it's like more clear than xi. So here we have to do 30 people. We will sum their total, like one person, then sum, then second person, then so on and so forth. There will be 30 people, and then divide them by 30. So this would be, again, This would be an average age, and this would be the average age based on the just on the sample. So for example, the average age comes out to be 34 years from the population, and this comes out to be 33.5 years, or it can also come around 32 or even 31. But it's a representation. It's just a representation of the whole population. And this is the aim. This is the aim that we can, with how much confidence we can say. So the whole purpose of this chapter, statistical inference, this topic is mean we have a sample, we have gathered a sample, and it also depends how many samples. So one way is to take just one sample and be happy with it, but you say, okay, I will do a random sampling, but I will do this sampling 10 times. 10 different samples I will collect, and make sure none of the people are actually who are in the first sample are not in the second sample, and then those people who are in the second sample are not in third, fourth, and fifth, so on. So then you collect multiple samples and you talk about like how much they are good representative of the population, or how accurately you can actually use that information for population. So this is one important statistical technique. So we use different statistical technique, and one technique is called inference. So we are taking inference from the sample and how that can be a good representation of the population. And if there's an error, because there will be some error, how much is the error and how can we quantify that error? So this is the whole purpose of this chapter. So moving forward, the same thing they're saying about statistical inference uses sample data, like as we talked about, to make estimates of or draw conclusions about one or more characteristics of a population. So characteristic is like average age or average salary or average height, anything about your sample. So if we are talking about people, we'd say, okay, their salary, their age, their height, their how many male, how many female are there, different things. So this is one example. And if we take the population of the school and say there are 15,000 students and we take a sample of 15 students, then what are their GPAs? So average GPA of UMass Lowell is, we don't know, but how about if we have 15 friends and we say, okay, let's take an average of our GPA, that would be a representation, or that would be an estimate, or it can make some conclusion about the actual GPA of the whole UMass Lowell, average GPA. So in this way, you can make inference. So same thing, the sample population, the population from which the sample is drawn. So the sample population. So there's a population and we took a sample from it. So we'll call it a sample population. And frame is a list of elements from which the sample will be selected. So it can be some list of elements, like say UMass Lowell female students, or you say, okay, male students. So you say, okay, so there's a frame of reference. You took a sample based on that frame. So the first concept we have to take, okay, how can we do the sampling? So here, the first thing they are talking about is parameter. So parameter is any factor, any characteristic of the population. So age, size, gender, race, ethnicity, GPA, anything, ability, IQ, SAT score, whatever. So it's like different characteristics. In machines, we have different characteristics like age, how much was the lifetime, wear and tear. Different things you can think about is their parameters. So any characteristic of the item which is under consideration is called a parameter. So now there can be two kinds of sampling. A simple random, there's a sampling which is called from, so you can take a sample from finite population or from infinite population. So finite population, so there's a small difference between finite population and infinite one. So here they're talking about is like sampling from finite population. First, we have to understand what can be a finite population is. For example, there are 30,000 students who have passed out or who are in this school. If they're, and then you take a sample from those 30,000. But there's an example, like if I say, if if I want to know what is the gas price, for example, what is the gas price, or what is the average gas price in America? All right, so, and I'm very curious, like how even in cents it does matter. Like if someone is selling it 1 cent above or lower or different prices. So I want to be very, very accurate. And I say, okay, what is the population you're talking about? So I'll say, well, I have to check each and every gas station in America. Okay, so each and every gas station I have to check with them, either go there, call them, or just check with them at what value they are selling the gas. All right, so this is my population, but I even don't know how many there are. I don't know the total number of population, but still I can take a sample. So that kind of example is an infinite population, and I can still take a sample and we'll talk about it. But first we have to talk about just finite population. So finite population which is countable, easily countable. So we know how many there are in the total population and how can we select some of them. So we do a simple random sampling in this case. A simple random sampling, also known as SRS, is like every element from the population has the same probability of being selected. So if there are 100 people, 100 students, and I will select 10 students based on simple random sampling, I will say the probability of getting each student is 0.01, 0.1. So probability of getting each student is actually 0.1. So SRS, so the probability of selection is equal for each person. So there is like, it's not like one student has higher chances of getting selected or the other, everyone has 0.10. So there's a 10% chance that you can be in the sample. So it's simple random sampling. You will flip a coin, and if head comes, you are in the sample. If not, you're out of the sample. All right, so you can do like this. And we just need 10 students. Once we get the 10 students, we'll stop the sampling. So this kind of a sampling is called simple random sampling, in which every selected participant, every selected element, every selected thing has the same probability of being selected. So if one student is selected, the other person still have the same probability of being selected. Its chances will not go down or up. All right, so to do this in Excel, they have actually showed us. So there is this Excel data set you can download from online from the textbook. What you have to do here is go to your textbook and then click on the data set. There is a small tab. It's called data available, file available. So click on that. It will download the salary data set, and it has, I think, 2,500 or some people there. There's a 2,500 different salaries for employees. And now the question is, how would you do simple random sampling? How would you select a sample of 30 people? So actually the textbook talks about it, and they have given the step-by-step way to do it, and you can actually generate a sample which is pretty much random. And by random, it means we are doing some kind of flipping of a coin, you know. So by random, it's just based on chance. It's not like preference. It's not my, because I like people who have higher salary, I will select them for the training. No, it's purely based on flipping of coin. For example, if head comes in, we will select this person, otherwise next person. That's just based on chance. So and then in computers, how can we flip a coin? It's hard in computer. How can we make a toss? And when we have thousands of people, like we have 2,500 people, and we will start from the first person. For example, we start from this person, and we are like, okay, this person has an annual salary of 55,769.50, and we are like, okay, let's select this person, or don't select. How we are just going to use some kind of a flipping of a coin, and computer can actually generate probabilities. So we say if you are above a threshold like 60%, you are in. If you're not, you will just below. So in computer, in Excel, you can use a command called equal rand and brackets. So once you click, it will give you a number like this, or some number dot dot dot. So it will be a decimal number, and it's like probability of getting selected this thing. So it's coming from computer um, computer memory, or it's based on a function. So my point is, how exactly something is random. As we do a flipping of a coin, computer generate every number based on some formula. And things cannot be random at a lot. A lot of time, computer fail to produce random number, like a large number. Like if I say 1 million, produce 1 million random numbers, after maybe 50,000 or 100,000 or even a million, it will start repeating the same pattern. So it's following a pattern because this random number is coming from some kind of a formula, and then it will start repeating it after maybe 1 million or 10 million numbers. The pattern will show up. So initially in computer science, tried really hard to make this thing random, but only way actually we can flip a coin and select a person. That's random. And some people say, okay, the number of times our eyes blink is actually random. So the point is, it's all based on chance. There is no pattern. So if we do a flipping of a coin, we are pretty much sure that 50% of the people will be selected. and 50% will not be selected. So you already have a chance of 50%. If we roll a dice, each person has a chance of 1 by 6. So if I say, if I get on a dice, on a fair dice, if I get a 6 on the top, I will select the person number 1. If not, I will kick them out. So if I roll the dice and 6 doesn't show up, or 6 shows up, this person is in. If 6 show up, if person 2 comes in and 3 shows up, this person is out. So it's like the chances of getting 6 is 1 by 6. So for a fair dice is already 50%, but with a coin it's already 50%, but with a fair dice it's much harder to get in. It's 1 by 6. However, in computer we can just use this rand and generate numbers. So what they did here, they generated rand, they used command and generated all the numbers, and then they just put in the first one and then copied all the way down. And then in the second step they just sorted the random numbers, so from the minimum to the highest. And these numbers are generated totally random, so it's between 0 and 1, but there is no pattern. It's totally random. Maybe there's a pattern, but that is after like 100 million numbers or 10 million numbers. After that it shows repeating it, but overall we can say it's pretty much random. So once you sort it, so like for example here we had 1 2 3 4 employee ID, but now it's 8 1 12 1 4 1 1, and so on and so forth. So it's pretty much random. And if we just select the top 30, that would be our random sample. So we just selected top 30 and lowest to the highest by the selection of the random number, and just only 30 employees is selected out of 2500. This is our random sampling. So we have made our sample, which is SRS, so which is based on simple random sampling, and everyone has the same chance of getting selected. But we just need, out of 2500, we just needed 30 people, and we selected them. So next they're talking about infinite population. Infinite population is with an infinite population, you cannot select a simple random sample because you cannot construct a frame consisting of all the elements. So here we just do a random sample. This is kind of a problem like we talked about before. For example, if I want to know about the gas price, average gas price, or the highest gas price in America, and I say, okay, what can I do? I can go out and start by finding gas stations. Well, I say, okay, I even don't know how many gas stations can there be. So there can be maybe 50,000 gas stations all over the country. But I say, okay, maybe there are more, there are less. But I just don't care about the total population. What I care about, there can be whatever number is. I can do some random sampling. What I can do, I can select 4 from my town, 4 from my neighboring town, 4 from other and some other towns, and then I can say, okay, I checked total 25 or 20, 30, 32 samples. I checked 32 gas stations, and the highest gas price I found this. So this is my random sample. I just took some from my population and based my inference on that. All right, so here each element is selected independently, but so it doesn't matter like if I have selected one element, the other one can be selected or not. It does not matter. I just selected 4 things, and it's just randomly I tried to pick gas stations. So this is also true in some cases, but mostly we usually do simple random sampling. And here in the infinite population random sampling, it's much harder. So we have to be more careful that our results don't become biased. So so the next important point is the point estimation. All right. So what is the point estimation? We have to understand the concept of, before getting into point estimation, I think we should understand what is the concept of expected values and standard deviation. So the first thing we have to understand is, what is expected value? This is in chapter number 5. You guys should know this thing. And we actually did in decision analysis in chapter 15, expected monetary value. So we had this concept. So any distribution. So what is a distribution? So consider distribution. We call distribution, we call the distribution. So we have a sample. For example, going back to the salaries example, or the employees, in which we have 2,500 total employees, but we selected a sample of 30 employees, and then we say, okay, the population characteristic, which is which is the salary. So the salary of the employees, we can say it has a distribution, which means the salary has a pattern. So if this is the salary, like there, this is the salary, like starting from zero. Some people have 1,000, some people have $2,000, 3,000, okay, and some people have like 2,500 or $4,000. All right, so so we have and then we say, okay, how many people have 1,000? So we say, okay, out of all of them, out of 2,500, maybe 10% has 2,500. Let's see, just a second. So my daughter is here. She's trying to hold my pen, and I will just resume this video. Aliza, just a second. Aliza, no. नहीं चल रही है